Well, I'm Robyn Wilson. I'm an associate professor in the School of Environment and Natural Resources. I'm a behavioral decision scientist, so I'm in the kind of social science group there. And yeah, Doug has tricked us all into doing very challenging presentations. I will be the first of many with a script, trying to stick to my 30 seconds per slide as best as I can. So the first thing I thought I would do, just to give a broad overview of what I focus on, is I created a Wordle. Do we have any Wordle fans out here? Yes, I love Wordles. So these are just titles of my journal articles and the journals I publish in, just to give you kind of a sense of the sorts of things that I do. So I'm a behavioral decision scientist. Like I said, I'm interested in how people make decisions under risk and uncertainty. My training and background is largely interdisciplinary, based on a combination of psychology, mostly kind of cognitive and social psychology, decision science, and then a tiny bit of economics, mostly behavioral economics. And most of my work is situated in environment and natural resources context. So I do a lot of work on the role of risk perception in decision making, and to what extent decisions are a function of more kind of heuristic or intuitive modes of information processing versus more deliberative or analytic ways of making decisions. So most of this work has been in the context of environmental problems. I now have no control over the slides, where I have focused on land and resource management decisions. So specifically, I've done quite a bit of work in carnivore conservation as well as wildfire management, where I've studied populations ranging from kind of members of the public and how much they support different management strategies to actual resource managers and the types of decisions they make to deal with these sorts of challenges. More recently, I've begun to focus on nutrient management decisions among farmers in the context of water quality policy. So this work on farmer decision making began several years ago when I was part of a team led by Alina Irwin out of AEDE that successfully received an NSF coupled human and natural systems project. And the main kind of research question of that initial project was, to what extent can we offset the impacts of climate change on downstream systems through changes in upstream human behavior? And the motivation for that project was just thinking about recent harmful algal bloom trends in Lake Erie and the recognition that these problems were a function both of human behavior but also of climate change. And when we think about what aspects of that we have control over, the only piece we can really control is the human behavioral part. We can't turn off big spring rains, we can't cool off the lake in the summer. What we can do is we can think about those agricultural land management decisions. And I would argue that although there are still plenty of research questions, and you'll hear probably from some other of the lightning talks this morning on that, that we know quite a bit more about why the blooms are occurring and what practices might be effective at reducing their impact, but we know a little less about how farmers might respond to those policies that we put in place and how likely they are to change their behavior. So what have we learned to date? Well, as a behavioral scientist, I'm looking at these decision-making processes, and we've learned, and I think we knew this in social science before, but that we often oversimplify the way we represent human behavior in these decisions. So we know that farmers are pretty diverse in the things they care about and the things they want to do. They're going to respond differently to different policy mechanisms. They're going to respond differently to changes in economic conditions, social conditions. And so we've been trying to model the likelihood of farmers adopting different conservation practices in response to these sorts of external mechanisms to account for that diversity in how they think and behave. So we've looked at everything from kind of farm and farmer characteristics to different beliefs that farmers have, and one of the kind of key findings to date is that one of our best predictors of conservation practice adoption is really farmers' confidence in their ability to implement practices and how effective they perceive those practices to be. Ultimately, with this understanding of farmer decision-making, we can then model how farmers might respond to different policies we put in place. So for instance, if we target our outreach, extension, and education efforts at increasing farmer confidence, we see that if we can increase confidence by about 60% among farmers in Western Lake Erie, we can see a corresponding increase in adoption of cover crops by 13% and of subsurface placement by about 20%. Once we understand these mechanisms and how they may increase adoption, we can then link them to spatial models to understand how such changes in behavior as a function of increased confidence may impact the downstream system. Our initial efforts to link these potential changes in behavior to downstream loading of total phosphorus indicate that by increasing practices to this degree, that we could decrease annually total phosphorus loading by 150 metric tons. So on a given year, that would help us meet the 40% reduction target that's been put out there for Lake Erie. So in sum, this early work was really aimed at linking the human and natural system by asking the question, how do we get the right individuals to change the right behavior? These models of farmer behavior in response to various policy mechanisms are being integrated with land use and watershed models that inform our understanding of downstream ecosystem services under a variety of potential climate futures, and you can kind of see that represented in this diagram. This work has led to several recently funded projects allowing us to continue our work in this complex coupled system. One project was funded by the EPA Great Lakes Restoration Initiative. This is led by the Great Lakes Commission and in partnership with Michigan State's Institute for Water Research. And here we're evaluating how effective the $100 million that's been spent in the Great Lakes through this initiative, how effective that's been at actually improving conditions. And that's $100 million since 2010. So in this project, researching the effectiveness of agricultural programs, we'll be looking at both the social and the economic impacts of those investments across 4 Great Lakes priority watersheds, one of which is the Maumee here in Northwest Ohio. Another project led by Alina Irwin was an NSF Innovations in Food Energy Water Nexus program. Includes Doug Jackson-Smith and probably some others in the room as well. And in this project, we'll develop a new integrated modeling framework that accounts both for individual land use and management decisions, which is the role that I play in that, but also regional demands for resources and environmental impacts. We'll apply this model to the Great Lakes region and evaluate the implications of deglobalization for sustainability and societal well-being. Finally, we have 2 projects that are pending right now at USDA's AFRI program. One that I led on resilient agroecosystems in a changing climate. And here we're looking at how farmers respond to climate variability and the subsequent impact of these shifts on both production and the provision of ecosystem services. A second was led by Jay Martin, which will focus on identifying and remediating legacy pea fields in western Lake Erie. So I thank you for your time. Lightning talk accomplished. I'd love to talk with you more about this later. Enjoy the conference.